Today we're going to talk about what's called the triangle inequality theorem. And what this theorem says is that the sum of any two side lengths of a triangle is going to be greater than the third side length. Right? So if I had a triangle ABC, if I added the measure of side AB to the measure of side BC, the sum of those has to be greater than the third side. And I can work my way around the triangle. So the measure of side BC and AC has to be greater than the third side AB. And then the measure of side AC plus AB has to be greater than the third side BC. All three inequalities must be true, but we only need to show the sum of the two shortest sides that it is greater than the longest side in order to prove that the three lengths given can actually make a triangle. All right, so again, you don't have to show all three, but the inequality that I do need to see is the sum of the two shortest sides that it's greater than the longest side. All right, and that's important. It can't just be any random. It specifically has to be two shortest greater than the longest. All right, to show that it can't be a triangle, right, that the three lengths don't work, you only need to show one of the three is false. And of course, it would be the one that we're going to check, the two shortest has to be greater than the longest side. All right, so notice it says, determine if a triangle can be formed with the given side lengths. All right, we're just determining if it's a triangle. Explaining your reasoning is show the work, show the inequality that you're checking. So when you look at your three numbers, identify your two shortest sides, and that's the one I want to see. So 12 plus 4 has to be greater than 17. And when you do the math, notice it is not. 16 is not greater than 17. So those three numbers cannot be a triangle. All right, they would not connect to make a triangle. B, my two shortest, again, are the 24 and 8. So we're going to add those together and show that it's greater than 30. So 32 is greater than 30. So this can be a triangle. 5, 5, and 10, that just tells me it's an isosceles triangle. Two of my sides are the same, and they happen to be the two shortest. So I'm going to check the 5 and the 5, add those together to see if it is greater than 10. You cannot have equal numbers because 10 is not greater than 10, and there is not an equal sign underneath of my inequality. So that doesn't work. This cannot be a triangle. Now I am going to add an example D here because sometimes if, let's say I had 2, 3, and 3. So again, I know it's isosceles because two of my sides are the same, but to grab the two shortest, definitely the 2 is one of them, and then you would just grab one of the two congruent sides. So I would check 2 plus 3 needs to be greater than 3. So 5 is greater than 3. So this one can be a triangle. Okay. The other part of the triangle inequality theorem is you're going to be asked to find the range of the possible measures for the third side. So if we know the two sides measure 7 centimeters and 14 centimeters, what you do is you're going to add them. So 7 plus 14 is 21. Then you're going to subtract them, always high minus the low. We're not going to get any negative answers. So 14 minus 7 is 7. So that means my third side would be between 7 and 21. That's what you're going to write. Now, if there's a specific name given to the side that we know, let's say the side length is, AC, then we would put the measure of AC in the middle, not just this word third side, okay? All right, sides and angle relationship. If we have two sides of a triangle that are not congruent, I know the larger angle will always be opposite the longer side. If two angles of a triangle are not the same, not congruent, then the longer side will be opposite whichever the larger angle is. All right. Now here, the way that I'm wording this, these should actually have bars because I'm naming the sides. All right, so if side AC is the longest, then the angle opposite it, which is angle B, is going to be the largest angle. If side AB is my shortest side, then the angle opposite it, which is angle C, is going to be the smallest angle. And then conversely, if angle B is the largest, then I'll reverse my arrow. So I know side AC is the longest side. And if angle C is my smallest, then opposite that, which is side AB, will always be my shortest. All right. So notice we want the bars, we don't want M's because we're just naming the parts. Now, when we start writing inequalities, all right, we use inequalities with numbers. So now we're talking the measure of. So when it says to order the angle measures of triangle ABC from least to greatest, all right, we won't have the bar, or in this case, we're doing angle measures. We will have the M because we're talking about the measure of. So when I look at this, I see my shortest side is the 29 feet. So the angle opposite that is angle B. So the measure of angle B will go first. That's my shortest. I'm going least to greatest. All right, then I want the middle. So 44 feet is the next shortest. So across from that's angle A. So the measure of angle A goes there. And then my longest side, 50, is opposite angle C. So that's how they would order from least to greatest. All right, when I'm ordering the side lengths, I need to know all three angle measures. Notice one is missing. You must find it first. So if I add these two together, right, we get 145, and I'm going to subtract that from 180 to figure out what measure is missing. So what's missing is 35 degrees. Now I can go, as it wants, least to greatest. Pay attention to that because on the worksheet that you'll be practicing on, sometimes it reverses that and wants greatest to least, okay? But we're going small to large. So it's looking for my smallest angle. The side across from that is AB. No bar because I want the measure of, all right? The next smallest is the 62, so across from that is BC. And then my largest angle, 83 degrees, is across from AC. So that's how the three side lengths would arrange, least to greatest. All right. You should be ready to practice.